Hello friends, welcome back to our channel STM Mechatronics, and in this video we will see how to configure the GPIO pin as an input. So for our main agenda will be like configure GPIO port pin as an input. In the last video we have seen how to configure the GPIO pin as an output. We'll come over here, right? We are going to set the mode register. Like if you see this data sheet, right, user manual. So for each port pin, right, we have two registers, two configuration bits. Okay, basically two configuration bits. This is for port pin 0, this is for port pin 1, this is for port pin 2, likewise. So in GPIO A, B, C, D, E, in each GPIO we have total 15 pins which can be configured as an input, output, alternate functionality or an analog. So for each GPIO pins we have two mode configuration bits. So there are total 4 configuration, right, mode configurations. So we will be needing 2 bits for each port pin. Now it is like 32 bits register we have, right? So I'll start from 0, 0, 1, bit number 2, 3, 4, 5, 6, 7, 8, 9 and so on, 31 and 32. So these 2 bits are used for GPIO pin 0. These 2 bits are used for GPIO pin 1. These 2 bits are used for GPIO pin 2. These 2 bits are used for pin 3. Right? Then this is for pin 4 and likewise. So bit number 30 and 31 will be used for pin number 15. Now we are interested to set this pin 1, GPIO pin 1, GPIO A pin 1, and we want to set it as an output. So we want this as an in output mode. So we will have to set these bits as 0, 1. So over here you can see that if we write 0, 1 to respective pin bits, it will be configured as an output mode. So over here we will have to write 0 and 1 because we are using pin 1, not pin 0. So we'll calculate last 4 bits only, 0, 1, 0, 0. So if we calculate the hexadecimal, it becomes 0x4 single byte value. So what we will do is in the GPIO mode register, GPIO A mode register, we'll write 0x00 00 00 00. These are total 8. Now over here we will write 4. This will configure GPIO A pin 1 as output. Now this is done. Now we want to configure pin 3 as an input. So we will have to write 0, 0 on that pin. So what we will do is, now we want to configure pin GPIO pin 3 as input. So what we will do is, we want to configure GPIO pin 3 as an input. So we will have to write 0, 0 over here, but rest of these bits should not be affected. So what we will do is, we will configure the value as an FF FF, 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 then FF, 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 FF. So these four will be like unaffected if we end with 1111, 11 and 00. So this value instead of F will write 3F. Now what we are doing, I'll explain it to you in short. Now we'll make it and FF, 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 3F. Now what we have done over here is, so whatever the value of the port pin, it is unaffected. Only bit number 6 and 7, it is set to 0. So what we have done is, we have used the AND operation. So if we AND any bit with X, we get X. And if we AND any bit with 0, we get 0. So if we AND with 0, then we get 0. This is the principle that we have used. Now we have marked all these bits as FF or 11. Only bit number 7 and 6 we made it 00, right? Bit number 5 and 4 we made it 11, and rest of like all the remaining 4 bits we kept it as F11, because we only wanted to set bit number 6 and 7 to 0. So that's what we have done over here. So this will, like, if we make the binary of these last 4 bits or last 8 bits, it will become like 1111, 1111, 1111, 1111. This will be FF, 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 again FF, FF, 0011 and 1111. So that's how we have calculated, like this is 3F and rest of the FF. So FF, so F, 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 3F. So this way we have made it. Now coming over here, the next register is of output type. So we'll come over here, GPIO mode. We want the output type. Output type. So in the output type register, we have either push-pull or open drain. So we want our port pin to be in the push-pull configuration. So we will keep the reset value, because the reset value is of 00, and by default it will be in the push-pull configuration. So we won't be modifying this push-pull register. So we'll write over here as by default or on reset, the pin is in push-pull config. Now coming to the third register, output speed register. So again over here we are going to use the default setting, which is low speed. So the reset value is 0000 for port B, and for other ports it is 0000. So like we are using GPIO A, and for all the pins the default setting will be low speed 00. So again, by default on reset, the speed is in low speed. So that's why we are not going to configure it. Now comes the next, like pull up, pull down register, right? So if you see, again for pull up we have 2 bits for each port pin. So if we configure it as 00, then it will be no pull up, no pull down. If we configure it as 01, it will be pull up. If we configure it as 10, it will be pull down. If we configure it as 11, it will be reset. Now we want to configure it for these 2 bits, bit number 2 and bit number 3, and again for bit number 7 and bit number 6. So we want the internal pull-up to be enabled. So we will have to write 0 1 0 0 0 1 0 0. So this value becomes 0 1, that is 4. 0 1 0 0 becomes 4. 0 1 0 0 becomes 4. So we will go over here, pull up, pull down. For output, first we will configure pull up, pull down ampersand equals to 0x00 00 00 00 04, right? So this will mark GPIO A pin underscore 1 as pull up. So enable internal pull up. Internal pull up. Now same thing we will have to do over here, but only the bits will be changed, right? 00 00 00 00 40. Now over here these things remains the same. We are enabling the internal pull up for GPIO pin 3. GPIO A pin 3. We are enabling the internal pull up. Now comes the next register, that is input data register. This will be needed, and output data register will also be needed. This bit set register will also be needed. Then port configuration lock register. This is not needed, so we can ignore this port lock register for the current moment. And alternate functionality low register and alternate functionality high register. Now we are not using the alternate functionality as it is mentioned in the mode register. We have not configured any of the two pins in the alternate functionality mode. That's why we are not going to attend, or we are not going to give attention to this alternate functionality registers for current moment, right? For currently we can ignore those. Now input data register and output data register. Like we have port pin number 1 as an output. So what we will do is output data register. We will configure this register and we will write 1 to this. So writing 1 to this port output data, it will reflect. So if we write 1 over here in bit number 1, GPIO A pin 1, it will output logic 1. Okay, logic level 1 on the pin 1. If we write 0 over here, it will give 0 to the logic. Same we can use using bit set reset register, that we will see later. So what we will do is in while 1, we will over here use uint 32 underscore t, which is defined in standard int. We will use I as a variable. We will give the initial value of 0. Now we will make I equals to 0, I less than 10,000, I plus plus, and we will give simple ASM instruction, which is underscore underscore NOP. So this is the soft delay that we are using. Now what we will do over here is, as I have mentioned, we will be using this output data register to write to the port pin 1. So the output data register. Now we will have to write 1 to this. So we simply want 0x02. This will write GPIO A pin underscore 1. It will set this pin. Now we want to clear that pin. So how we are going to do that is like GPIO A underscore output data register ampersand equals to 0x ff 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 ff, right? So only bit number 1 has to be made 0. So the last 4 bits will be like this. So this becomes 1 0 becomes E and 0 1 becomes D. So this becomes this. So we can write like GPIO pin 1, we are resetting it over here. We are resetting it over here. Then we are giving this delay. So first thing we'll check, we'll compile our code and check whether the pin is configured as an GPIO output or not. Go in the settings, then post build output, click on build hex file, and apply and close. Now build this. Okay, so it is giving error. We'll be making this pointer, then pointer, or address, address, address. So over here we have to make some adjustment. First thing, we have given the correct address, but all these registers are like pointing. We have to use it as a pointer. All these macros we have to use it as a pointer. We have made it proper. Now what you need to do is you just need to simply add this uint32 underscore t and pointer. So all these variables, all these macros are like pointer, and we'll have to dereference this and write the value to this memory location. So that's why we have to use this as a pointer. Once you write it, build the code, we'll have zero errors. Now we'll go in our code, open it, go in the bare metal one, bare metal STM32 in GPIO. In debug, we have our GPIO input hex file, right? And after running this, our GPIO should like toggle. Now what we'll do is, I think we have given large delay, so we'll reduce this. Again we'll build this. And one more thing, right? We have reduced the delay. Now if you can see this, our LED is continuously on. That means there is some problem. Now we have to debug that problem and resolve that problem. So what we need to do is, these are pointers to memory location. Yeah, so we have our oscilloscope connected. Right, you can see this, our port pin is toggling, but it is toggling very fast. So the delay that we have reduced, we have to actually increase it. We don't have to decrease it, we have to increase it. So we'll make that value as 1 lakh, so that we will be able to see the port pin is actually toggling. Now you can see that still it is very fast, right? Still it is very fast. Now what we will do is, it means our code is working perfectly fine, right? Now first thing, like what we suggested is, when the button is pressed, or when the switch is pressed, the LED toggle should stop, right? When it is released, the LED toggling should continue, correct? Now we have configured our pin 3 as an input, pin 1 as an output, and we have checked that this pin 1 as an output is correctly working, right? It is working as an output pin. This is perfectly working. Now we need to verify this, right? GPIO pin A, pin 3, GPIO A, pin 3, it is working as an input or not, correct? So we'll go over here. Now we have input data register, and we need to check bit number 3. So we have connected our pin. First we will see over here. We have connected the internal pull-up also and external. Just for precaution, we have connected external pull-up also. It should be connected GPIO pin 3, and the switch is connected to the ground. So when we say like the switch is pressed, so the pin state of PA3 will be 0. So that means what we need to check is, if bit number 3 of in GPIO IDR, if it is equals to 0, then stop the toggling of the LED, right? So here we'll do the same, right? So if GPIO A input data register ampersand with, right, 0x 0FF FF, or we'll simply check that bit number 3. So this will become like 0 0 0 1 0 0 0 1. So it becomes 1 0 0 0. So the last bit becomes 8. So if GPIO input data register and 0x0008, that is bit number 3, if it equals to 1. If it is true or 0x08, this value becomes 0x08, or we can simply write as if it is not equals to 0. Basically, if it is not equals to 0, it means it can, like, it is 8. Then we will run this code. Then we will run this code. Else what we will do is we will stop toggling of the LED. GPIO pin reset. And we will stop the toggling of the LED. Now we will build our code. We still have 2 errors because we have not used it like this. Right? Now we have 0 errors, 1 warning. We will build our code. We have built our code. We will load the hex file. Click on OK and run. Right? Now here you can see that the switch is already pressed, so the LED is not toggling. As soon as we release the switch, our LED starts toggling. This means we have achieved our goal, right? So we have achieved our final goal, right? Like this way you can configure the GPIO port pins, right? GPIO registers, and in order to achieve the port pins as an output or input. In next lecture, what we will do is we will see how to configure the GPIO pins as an alternate functionality. Then the analog functionality we will see. Right? Now you can see that, like, we have made our code very bulky. We have written this each register, right? Mode R, output type, output speed, pull up, pull down, input data, output data, bit set, reset, log, AFRL, AFRH, right? We have given the separate memory location, added the offset to it, right? So what will happen if I want to change the port pin from like GPIO A to GPIO B, right? I'll have to write this whole structure or whole macros for GPIO B and then configure it. So how we can avoid it is, like, we can write the structure, one structure, like mode for this mode register, output type, output speed, pull up, pull down, and using this base address of the GPIO, we can assign values to all these registers, because these registers are similar, exactly similar for all the other GPIOs also, all the other GPIOs also. That's why what we will do in the next lecture is we will create separate file gpio.h and gpio.c. There we will write our structure, right? GPIO handle structure and user defined, like how we can configure the pins from the user, right? How user wants to configure the pins. So for that we will write one structure. So one structure will be for these registers, one structure will be to access this register or handle structure, and one will be from the input, like how the user want to configure the GPIO port pins, either input, output, analog, or alternate functionality. So that we will write in the next lecture. So if you like the explanation, if you enjoy this video, give it a like, share with your friends, and thanks for watching this video. We will see you in the next video.